All right, everyone, we're going to get started in just a minute, just allowing individuals to come in the room. Thank you on behalf of NOCO. Thank you, everyone, for attending this webinar today, Actively Managing and Operating Part-Time Shoulder Use. My name is Matt Adam Hobbs. My name is Matt Jasnos. I work with ITE, and on behalf of NOCO, I will be facilitating this webinar today. Like I said, we'll just get started in just a moment. We'll hand things over to our moderator. Thank you, everyone, for joining us today. All right, it's 11:01. Hello, everyone, and welcome to the Traffic Management Center's Actively Managing and Operating Part-Time Shoulder Use. My name is Matt Jasnos, and I'll help facilitate today's webinar. As a quick reminder, at the National Operations Center of Excellence, we offer a variety of resources to support the transportation systems management and operations community. You can go to NOCO's website at transportationops.org to browse through links for TSMO resources and news. Previous webinar recordings and case studies can be accessed from there. Now, I'll cover a few logistics for today's webinar. We're recording this webinar, and the recording will be available on NOCO's website, usually within 2 to 3 days after the webinar has been completed live. All the attendees are encouraged to stay engaged by using the Q&A features for questions and chat features for comments. These are both on the bottom of your screen. If you'll see the bar that will pop up once you scroll over it. We have a question and answer session at the end of the presentations. So if you have any questions, we encourage you to enter them in the Q&A area as they come to you mind at any time. Also, please feel free to enter your name and agency in the chat to say hello to your peers. Now I'd like to hand it off to our moderator, Jordan James. Jordan.
Hi, good morning. I am seeing the first page of the slide. Do we have the opening poll? All right, and I am sorry, Matt, I do not have the information for the poll. Hopefully the poll is popping up on everyone's screen. If you can see it, I believe there's 2 questions. You may have to scroll down to see the second question. Hey, Matt, it looks like the chat is saying that the results are showing and they're not able to answer the poll.
Maybe that's because we tested it earlier. Hold on 1 second. Share results and try this again. My apologies. We had to relaunch the poll. Here we go. Can everyone see that now?
Yes.
Excellent. And as Jordan stated, you may have to scroll down to see the second question.
All right, Matt, I think that is probably enough
All right.
time for everyone to answer the poll. So thank you everyone for doing so. Looks like we have a majority of public state agency representatives. All right, can we move on to the agenda? All right, here are the topics that will be discussed today. As Matt mentioned, my name is Jordan James. I am with the Nevada Department of Transportation. And you can see the topics and presenters that will also be speaking today. If we go on to the next slide. Before we jump into the main topic, we're going to quickly give an overview of this webinar and the TMC pooled fund study. So on the next slide, we have a disclaimer just stating that the views and opinions expressed by the presenters today do not necessarily reflect those of FHWA or U.S. Department of Transportation. Also, any products displayed in today's presentation are not necessarily endorsed. The government does not endorse products or manufacturers. And also, anything stated in this presentation does not have the force or effect of law, is not meant to bind the states or public in any way. Next slide. All right, so today we're going to be talking about part-time shoulder use. We will be identifying potential opportunities for this, as well as understanding the needs and requirements to operate such a program. And finally, we will hear about policies, challenges, benefits, and lessons learned with managing and operating a part-time shoulder use program. But first, we're going to learn a little bit about the TMC pooled fund study itself. So next slide. The pooled fund study is currently a group consisting of 25 members of public agencies and organizations that voluntarily pool their funds together to conduct studies regarding traffic management centers and traffic management systems. So hopefully, if you are new to the pooled fund study or any of these webinars, the name is a little more intuitive. And the goal is to get all of these states and public agencies together and collaborate and use our resources to conduct studies and research on best practices and kind of help us optimize our operations. So you can see from the link at the bottom of the screen that the pooled fund study has a website. You can go to any search engine and type in TMC PFS, and it should be the first thing that pops up. You can go ahead to the next slide. The benefit of the pooled fund study is that it provides a forum and helps facilitate the sharing of information and practices among these various groups and helps us to collaborate and see what other states are doing so that we don't have to reinvent the wheel. It also helps provide resources and helps develop technical documents and research to help us find solutions to challenges and issues that we are currently facing. So for more information on joining the pooled fund study, you can contact John Openberger. His email is provided at the bottom of the screen there for you. Next slide, please. Here is a list of 9 current projects that the pooled fund study is undergoing. as well as 3 upcoming projects. And on the next screen, there are also 3 more NCHRP projects that are supported by the pooled fund study. Next slide. So the pooled fund study is partnered with FHWA and the NOCO, National Operations Center of Excellence. And so NOCO also has a portal for this specific group. Again, if you go to any search engine and just type in NOCOE, their website will be the first thing that pops up. If you can see the screenshot of their website in the top left corner, it says Knowledge Center. If you hover over that, one of the options is traffic management systems and centers. You can go to that and find a ton more resources on the pooled fund study. And I should mention that in both of these web locations, there are a ton of resources of past research and studies that have been conducted, presentations, past meetings. So you can find everything you need to know from either one of these websites. Next slide, please. Okay, so today's topic, as we mentioned, is actively managing and operating part-time shoulder use. Here is a quick schedule of future topics and their projected dates. These are all a part of the current series of emerging topics. So you can go to the next slide, please. For more information on the entire series, including the past 4 topics in this series and the presentations from those topics, again, you can go to the NOCO site or the Pooled Fund Study website. Next slide. Okay, I am now going to hand it over to Jeff Randall, who is the Senior Vice President of ITS and TSMO with WSB, and he will be discussing the challenges with part-time shoulder use.
Thank you, Jordan. The topic I'm going to talk about is outside of what we have typically seen in a lot of the guidelines published through Federal Highway, which typically has to do with how to implement and design and construct and operate. Part-time shoulder use is what I'm going to address are those issues that face agencies in managing and operating those. So agencies, next slide, please. I'm sorry. Agencies implementing and managing part-time shoulders are faced with a number of challenges and issues outside of those civil or highway aspects. These challenges could include traffic conditions that change, often sporadically, incidents, special events, traffic demand that exceeds the carrying capacity and additional capacity is needed. Traffic demand doesn't support adding that lane, which can be very expensive, as we know. Procedures may differ from other traffic management operations, such as variable speed and lane control. So challenges that face agencies can include operational strategies and agency policies, operating procedures that may need altering, legislation and policies may need to be developed to implement and manage the use of PTSU. Additional TMC or TMS resources and capabilities, for instance, surveillance and monitoring staff with special skills and training. So it's imperative that agencies carefully plan for the integration of PTSU with their TMSs. Next slide, please. How do we use it? Well, the strategy is to use shoulders as a part-time travel lane. It's been in existence for a number of years, originally as a TDM strategy to improve bus travel time and reliability, but part-time shoulders may be used to fulfill a number of functions like increasing capacity when needed to address congestion, allowing transit vehicles to use the shoulder to improve travel time, reliability, improve safety, reliability, and spreading the demand across capacity, providing access to emergency responders during congested periods. And it can be implemented based on time of day, typically referred to as static operation, that then the shoulder is used as a travel lane on a fixed recurring schedule. Typical only treatment for this is static signing. Alternatively, it can be used in a dynamic operation where it can be open and closed both on a schedule but on demand as needed. It can be used as a standalone strategy to address congestion and safety, or in a combination with other traffic management strategies like variable speed limits or, say, dynamic junction control. So TMSs, the assets that may be needed can include CCTV to examine the status of the shoulder before deciding to open it and to monitor the shoulder in real time during operation, changeable message signs to inform motorists of the status, typically in advance, to allow motorists to know that it's open, and overhead lane control signs, the red X, green arrow, to indicate the current condition for vehicles within the shoulder. Next slide, please. So the number of benefits provided by part-time shoulder use: it adds capacity when necessary, allows the shoulder to remain as a refuge for the rest of the hours of the day. It can improve safety by reducing severity and the number of crashes and improve reliability of travel during times when it's open. Helps agencies address political, physical, financial constraints. Those physical and financial constraints deal with lack of resources, either physical space or funding. Political constraints deal with competing views of stakeholders and decision makers. And some might want to reduce traffic congestion, others might want to limit additional pavement and any additional full-time lanes. So PTSU can be a compromise between these views. It can enable a flexible, cost-effective solution to managing traffic and improving the efficiency. One example to be used, which happened in Michigan as an example, they reduced their travel time from 22 minutes to 10 minutes when they opened up their dynamic travel lane. So next slide, please. What are some of the outcomes of using this? Well, we want to actively manage traffic based on changing conditions and circumstances, improve safety by reducing that number and severity of crashes, alleviate congestion, and increase system reliability by adding that capacity at times when it's mostly needed. Provide access to emergency responders to crashes and incidents, and understand the information operators need to actively manage and operate PTSU. Next slide. Some of the key considerations when planning and implementing can include policies, procedures, staff resources to support active traffic management and operations of PTSU. Operations staffing and scheduling to enable and operate the PTSU, operator position knowledge, skills, abilities, and operator descriptions needed to manage the part-time shoulder use operations. Next slide. Agencies are challenged with a number of things when implementing it. Some benefits may vary from site to site, and it really based on driver awareness of reasons to use the shoulder, driver behavior, road geometry can impede that. Part-time shoulder use compliance may be low if restricted use is not enforceable. PTSU requires significant investment in field devices, traffic management system capabilities, staff, and support resources. And implementation may involve agency policy changes, operating procedural changes, additional staffing, and additional training for operator skills. Next slide, please, Jordan. So the engine that drives the operation and management of part-time shoulder use is the TMS. So the TMS needs to have the capabilities and resources to support actively managing and operating the use of part-time shoulder use and perform functions including collecting and processing data, disseminating the information to travelers, emergency responders, and service providers, and ensuring the shoulder is clear of obstructions prior to opening and while it's open, and then monitor the shoulder in real time. Next slide, please. Agencies, they have to consider a number of issues when incorporating PTSU into their TMSs. This can include whether to implement PTSU based on time of day or on traffic conditions, that's static versus dynamic, whether to integrate ITS devices to support TMSs managing and operating part-time shoulder use. The agencies may need to develop formal operating procedures for PTSU. If to decide whether to automate the operation of PTSU to achieve desired safety and operational results, whether to increase operator staffing or improve operator skills and have to increase training, and importantly, to communicate with emergency responders and other agencies. Next slide, please. So when planning for TMSs to support, agencies can consider evaluating staff resources and their capabilities to manage and operate PTSU, identify training needs to effectively operate the PTSU, integrating the PTSU into their existing TMS, consider implementation of PTSU on a regional basis, existing policies and processes to actively manage and operate the PTSU, as well as what existing legislation is in place and needs to be changed. Lastly, to evaluate the availability of supporting devices that are needed to display shoulder status information to travelers. Next slide, please. So a quick scenario that I'll go through just to give an indication of how it might work. So a TMS senses the reduced speed on the network and increased traffic along a section of the freeway. The TMS analyzes current projected conditions, if there's predictability, to recommend opening the shoulder to accommodate traffic and improve travel reliability. The TMS operator or TMC operator accepts that recommendation. Implemented operator uses the CCTV to verify first that there are no obstructions along the shoulder before the PTSU is opened and implemented. The operator dispatches service patrol in some cases or maintenance vehicle to confirm it's safe when the shoulder is open, so they'll drive the length of it. The operator then issues a command to open the shoulder to traffic after receiving confirmation that it's safe to open. The TMS then places a message on a CMS to inform approaching motorists of it that it is open. It changes the overhead lane control signs from the red X to green arrows. And the operator then monitors traffic flow on the shoulder using the CCTV cameras. And lastly, the operator initiates the procedure to restrict traffic from using the shoulder by changing the green arrows to red X's when traffic conditions return to acceptable levels, and puts notification on the advanced CMS that the shoulder is closed. Next slide, please. I'm going to talk about a few examples, 5 states in particular that implemented this. You'll hear more from Chris on how New Jersey, much more detail on how New Jersey implemented. Next slide, please. So New Jersey implemented PTSU along a 4-mile section of US 1. It stemmed from a congestion because of a lane restriction bottleneck. It opened initially statically on a fixed schedule, but then changed to dynamic operation. It includes lane use control signs, changeable message signs, and CCTV cameras. Operation required a New Jersey DOT traffic regulatory order to implement PTSU. An amendment was necessary later to extend the hours when it went to a dynamic operation. There are dedicated operators within the TMC initially that manage the operation of that. Now it's a function and role of all operators. They use extensive stakeholder and public outreach before the first implementation of the PTSU. Next slide, please. So Michigan implemented PTSU along US 23 in Ann Arbor because they need additional capacity during peak hours and special events. It did not require when they implemented policy or any staffing changes. Existing on-road maintenance personnel are used to sweep the shoulders to verify if there are any obstacles present, which might restrict the use of the shoulders for the traffic lanes. And one challenge that they experienced in first implementing this as a northern state was the timing of de-icing applications that required traffic to activate that. And I think Chris will likely talk more about that. I beg your pardon. Sorry, Chris, you're New Jersey. So the issue here is that traffic has to roll over the ice to activate it. So it's difficult when it's icy to first activate it. There's some danger because the ice is still present. Next slide, please. So in Virginia, they've operated PTSU for many years, originally in Northern Virginia on I-66, but that no longer is in operation there as they've widened and implemented managed lanes. On I-264 in the Hampton Roads area, the shoulders opened 2 hours in each direction on weekdays, and it can be open when predicted or current conditions support those changes. Commercial vehicles are restricted from using that when open to traffic. TMS operators manage the PTSU as part of their routine duties, so they don't have specific operators that operate the PTSU. The operators must develop, however, the needed capabilities before they're assigned to do it. So they have to be have some more extensive experience and then be tested before they're actually are allowed to operate the PTSU, but then it becomes one of their regular duties as well as other duties. So no additional staff was necessary when they first opened this to support the management and operation of it. Next slide. Georgia operates along a couple of routes, State Route 400 and I-85 in the northbound direction. Like Virginia, they operate on a peak period schedule. However, they may also be able to activate it dynamically as needed. Buses are restricted from using the State Route 400 shoulder. Trucks are restricted from using the shoulder on both routes. Senior TMS operators here called TMC specialists manage the part-time shoulder. Other less experienced TMS operators perform sweeps of the shoulders for obstacles before making recommendations to activate the PTSU to those TMC specialists. And SOPs for activation and management of their PTSU are reviewed and updated annually. Next slide, please. Lastly, Washington State DOT has implemented PTSU on various corridors, I-405 and highways 2 and 14. The operation is managed by their TMS. Washington State DOT recognized the complexity of part-time shoulders. So they've designated transportation engineering positions to manage this operation in the see. Next slide. So lastly, various lessons have been learned through these 5 DOTs in their implementation of PTSU. Dynamic PTSU, based on changing conditions, require more staff than the static time of day, day of week PTSU. Some agencies that initially used dedicated operators to manage PTSU found that the dedicated operators were no longer necessary, and the management could be done by operators with appropriate training and skills. Because of the complexity of PTSU, agencies benefited from training these operators in traffic operations and traffic flow theory, much like a traffic engineer. SOPs and management plans for PTSU should be reviewed regularly and modified as necessary. And lastly, there's a benefit in examining whether policy and legislation is needed or need to be changed in order to implement PTSU early in the planning process. Thank you.
All right. Thank you, Jeff. Now we have Liz Schneider Liz Schneider, who is a freeway operations engineer at the Wisconsin DOT. She will be presenting on Wisconsin's program.
Thank you, Jeff. Go to the first slide, please. The flex lanes is what we call, in Wisconsin, we call our part-time shoulder lane. We run it dynamically. They are 2 lanes in both, one in each direction. They run eastbound and westbound on a 10-mile stretch, which is on US Highway 1218 in Dane County, which is where Madison is. And it actually does cross several local jurisdictions as well as the city of Madison. Next slide, please. The preferred design came out of a Pell study. The project contained the improvement within the existing highway's footprint, and the design team did visit Ann Arbor, like you just heard about here, to look at their Highway 23 flex route. The project team also did visit with Ohio to see what was being developed on their smart lane, and brought back a lot of those practices. And we've maintained communication with both states through our process of developing and operating our lane. So we've had some real good teamwork interstate. Next slide, please. So the construction began actually in 2021. They had the region that supported this contract. They had to improve this highway. The pavement was deteriorating. The median barrier and the drainage were in very bad shape. And their goal was to build a shoulder lane and narrow the through lanes to accommodate that on the existing footprint. So there was not an expansion to the physical infrastructure. This was all replacing what was already existing. Next slide, please. So we'll talk a little bit about our operations and our policies. For example, when, where, how to close the flex lanes. Could we open them and close them partially, and how would we do that? What would be the traffic thresholds for opening and closing? And then how would the software support these procedures? These were all things that were in the works as the design and the construction were underway. One thing we decided was that simultaneous sweeps by the traffic management center's operator, who we call a specialist also, and the freeway service patrol deputy are part of the standard morning and afternoon opening processes. Next slide. To predict operating times, we developed speed tables, and these were created for every month of the year, and we used data from that National Performance Management data set to really map out the speeds. And this helped show us where traffic was increasing earlier along the corridor and where we could, which areas we needed to place the detectors to really capture those increasing traffic levels. So one of the things in those guidelines that was mentioned earlier, those federal guidelines, is they hope that states can identify when traffic is starting to increase and start maintaining that increase in demand to get the lanes open, because that time to open the lanes is not instantaneous. Next slide, please. We developed some policies and procedures for weather response. This is a nice picture of Dane County's highway department. They actually purchased tow plows when they heard the flex lanes were being designed, and that was going to be a reality. And it was about a year before they opened, and they trained their plow drivers on how to use them. So they do plow the flex lanes as a regular operating lane in the winter. Then on the right, there's just a picture of some ITS devices getting maintained. In this case, this was a repair. There was a policy developed also for the maintenance. And what we did is adjusted our statewide maintenance contract. We could only service these median mounted devices between like 9 a.m. and 3 p.m. So including mobilization for lane control. So there were some policies that we had to develop for that, including priority response. Next slide, please. So I mentioned the lanes were narrowed. The flex lane itself is only 10 feet wide. So in the months leading up to this, law enforcement was asking about how we were going to enforce the no truck policy. Originally, the signs that were going to be mounted over the lane simply said no trucks. So with about 3 weeks or so before opening, we swapped out the signs with this less ambiguous message, so it would be enforceable. Next slide, please. So operations are impacted by incidents most often. That's what's impacting operations. And we have a handful of other things that will influence when we have to open and close the lanes or shut it down. And that includes outages, but also different types of weather issues, as well as emergency maintenance. For the most part, our outages we've been a little lucky. We've had outages happen on the weekend or in the middle of the night. And because our TMC is 24/7, the overnight shift can recognize when there are outages on the flex lane here and call in for service. And we can get some contractors on site even before we open in the morning. So we've had some luck with some of the timing with our outages. Just a handful of outages has impacted our operation. Next slide, please. So there are a lot of agency resources needed to manage this. And here's a few that we actually manage out of our traffic management center. Our statewide TMC is in Milwaukee, and it's under the Bureau of Traffic Operations. The regional office, they hold the contract for the highway maintenance department, who does assist. But out of this bureau where we operate the lanes, we have a contract for our TMC operator positions. We also have a separate contract for the ATMS software development, on-site support, the ITS maintenance. That's a separate contract that we manage out of the bureau. The freeway service team is an additional separate contract. This service team on the flex lane corridor is dedicated to just this corridor, and it's staffed 6 a.m. to 6 p.m. on the weekdays. And then we had a performance measure contract in the beginning, and since then we've brought all this in-house, so we were able to not continue with that contract. Next slide, please. This is just a view of what we see on our traffic management software. On the left is the corridors dashboard. On the right is just the ATMS map. And I just wanted to demonstrate for monitoring the conditions and outages. The dashboard on the left monitors the traffic levels and also can flag an operator like you see here with pink rows when devices go offline. And then on the right, you can see just the icons change colors, and the software has a lot of features that help track the status and then control the flex lanes. Next slide, please. The media, I want to mention, is a really important partner with us. WISDOT does have public information officers, and that helps us provide a real consistent message because we've done media interviews on site in Madison, and then on site in our traffic management center, some radio interviews, a lot of print. The city of Madison and their media has been really active in keeping the public informed. So it's been a really good partnership. The DOT also has a web page shown here, which has some videos instructing how to drive the flex lane, a frequently asked questions section, and just some really good user information. Next slide, please. I wanted to just talk a little bit about this. This is the closing of the eastbound flex lane. And per guidelines, we have 2 red X at the end of the lane and the 3 yellow X indicating that the lane is closing at the end of the lane. And what was unique about this is that it's on a curve. There's a horizontal curve and a slight vertical curve. And this was modeled that it would be an issue with the merging in design. It's just off the right side of this picture is the left-hand on-ramp to an interstate. So this was modeled. And then on the next slide, I think I'm going to go to the next slide, please. We had in recognizing just the severity of the merging issue we had in this area, within just weeks after opening our flex lanes, we swapped out some signs and added some pavement marking. So we had done the design per standard and per recommendation, but we decided we had some opportunities to beef it up a little bit and give drivers some little more advanced notice. So this was one of our operational change, not an operation change, but an issue that we realized and made some changes right after opening. Some other things that have come up right after opening were recognizing our operating times. We did a lot of fine tuning on our operating times. We had events planned for this corridor. UW-Madison has the Wisconsin Badgers, that they play home games in the fall. So we have opening on weekend, we staff on the weekends. And so over the last couple of years, we've learned a lot about managing these events. Another issue we've tackled, which was mentioned earlier, is the certification of operators, training operators, and having backup operators. We have 2 dedicated specialists for operating the flex lanes during the week, but all operators are trained. And then with that having been a good couple of years now, we've actually started to launch a recertification training for the backup operators. One of the biggest questions we get from the public is, why aren't the lanes open all the time? We have some public comments thinking that it costs us more money to open the lane, to keep the lanes open. But at the same time, we have some people that have shared their thoughts that, it's really safe to have that shoulder there. And the lanes are closed for safety. They're only open when they're needed. So we try to get these messages, out to the public. And really having those shoulders there for a runoff area is really a safety feature of the whole corridor. Next slide, please. So enforcement was briefly discussed. We do run enforcement campaigns with the Division of State Patrol here in Wisconsin, and the local law enforcement agencies will support that. And just on to the next slide, please. So when we have speed enforcement campaigns, those are advertised. And this is just a couple examples. DOT has put out some posts and social media posts about the enforcement, as well as the media, and even our State Patrol has put out some media alerts, letting people know that we are going to be enforcing. Next slide, please. So some benefits. Improved travel time reliability, definitely. That is improved over 50%. The travel times during the peak hour in the key directions has decreased about 45%. We've been able to support closures for repair maintenance, relieve congestion during incidents. If you go to the next slide, please. This is just an image from that where we were able to keep the lanes open. I think this was almost a 20-hour construction, accelerated construction repair, and we were able to keep the lanes open for the entire day to really hold off the congestion, as it was less worse than it would have been, so to speak. And then the next slide, please. And then during incidents, right? So if there's a crash, it's something happening on the right lane, the right shoulder, we can open the lane. But it is important to recognize that we do keep the shoulder closed so we can provide a lane for first responders to access these crash scenes. And that's something that we have to assess really quickly, as quick as possible, with communication between our control room operators and the responders in the field. So once we get that approval, we can open the lanes. We can open the flex lane to get traffic moving again. Next slide, please. And one other nice thing we've been able to do is provide corridor status on our traveler information page on our 511 page. So this was not initially launched, but this was a 511 improvement after we had the lanes up and running. Next slide, please. So a few lessons learned, and you could keep advancing. The speed differential was definitely something we realized once we opened an additional left lane. So the left lane's a fast lane. We had a new left lane, which became a faster lane. So dealing with the speeding out there has been something that the agency continues to work on, continuing to do enforcement and get the message out there about safety. It is a truck restricted lane because of the width. So we do not have those heavy vehicles or those trucks in that lane, which tend to also slow down traffic. Our software support has been very high. We have on-site support, and we have had software updates over the last few years, which have brought additional features to our operations out here. Next slide. And that's all that I have for you guys today.
Thank you, Liz. All right. you can go on to the next slide. Our next presenter is Chris Straniero. Chris is a TMC shifts supervisor with New Jersey DOT, and he will be discussing New Jersey's program for part-time shoulder use.
Thanks, Jordan. Again, my name is Chris. Nice to meet you, everybody. I'm going to go over some of the standard practices and how we got to where we are now. Next slide, please. Obviously, a lot of us have experienced this. Route 1 had quite a bit of congestion and delays during the AM/PM rush hours. So naturally, we look towards the hard shoulder running. That's the name of our part-time shoulder use to reduce that peak congestion. Next slide, please. So our HSR allows vehicles to use the shoulder as a travel lane. This will be for certain designated hours, which we have at 6 a.m. to 10 p.m. and the 4 to 7 in the p.m. Obviously, we're going to let the shoulder be closed during off hours as it's a safety lane, right? HSR adds a lane without a need to widen the road. HSR was successfully piloted just south of the project of 2017 along Route 1 from Independence to County Route 522, which is Promenade. Next slide, please. So we actually have already implemented this 2024, the add-on to the HSR, which started at Promenade and made its way up to Erin Road, which was in North Brunswick. So far, it's pretty good. We have portable VMS signs out there to alert the public of upcoming shoulder usage and when it becomes terminated. This differs in a lot of ways from the original piloted program, from the original 4 mile that Jeff brought up earlier. This is an additional 3 miles taking us into North Brunswick. Obviously, we still have the same hours, 6 a.m. to 10 a.m. and 4 p.m. to 7 p.m., which we had an extension in the morning. Next slide, please. As I mentioned earlier, we're using these portable VMS to alert the public, not like the original, which has become permanent, which is the overhead signs with the lane closure indication with the X and the green arrows. Next slide. In addition to those portable message boards, we'll have extensive use of static signs to alert the public of current use, upcoming, and the end of shoulder use. Next slide, please. This will give the public a heads up on when they're permitted to use the lane by law, so there's no confusions. Next slide, please. Also, we have people that may be out of town, may not be familiar with what's going on. We have to give them a heads up when they're coming out of a shoulder because it's a great hazard. This is the greatest threat of a T-bone is someone that doesn't know that a shoulder's in use and they're coming into a live lane of traffic. They think they're safe, but we have set to put these signages in those areas are the greatest threat. Next slide, please. So it wasn't as easy as just, throwing some stripes down and opening up the shoulder, right? So we had to expand the right shoulder from 10 to 12 feet. But how do you do that with a highway that's set in length? Well, we had the shoulder shrink down from the left shoulder from 3 feet to 1 feet. So we were able to add to the shoulder's length. Obviously, we had to beef up on some of those shoulders. They were soft, so there was a lot of nighttime operations, and we had to raise some of the drainage and inlets so everything was up to par. A lot of raised pavement markers were implemented to get this project functional. Next slide, please. Here's a visual of how the everything shifted over. You can jump to the next slide. It'll show that now. How we have 3 lanes of 12 feet. So we're able to have traffic flow through there. This is Raymond Boulevard. This is like kind of a before and after shot. If you go to the next slide of how that changed and how we have those dotted lines where when we're in shoulder usage, you can flow through those dotted lines. Whereas if you're not, that is a shoulder, that is a decel lane, right? So we can get to those ramps. Next slide. So I have a video here of the activation of the HSR in the afternoon. We can go over that now. And you can see it's a smooth transition. The green arrows come through. The motoring public picks up on that. They know that it's time, and it's a legal time to ride in the shoulder, and we've just dissipated the volume of congestion during peak rush hour. So here at the STMC, we're responsible for visually sweeping those lanes. So as a part of this project, we were given quite a bit of video cameras all along this corridor. So we will look north, we'll look south, we'll make sure that there's nothing in that lane of travel. And if there is, we will postpone the activation of the system, which currently is on a schedule for the South Brunswick section, the 4-mile length. Right. So once we know that the lane is safe, we can open it up. Obviously, and we've chimed this on some of the other speakers, weather can be an issue. So when I'm supervising, I like to stay in touch with the Central Regional Emergency Operations Center to make sure that our crews are plowing those lanes. And once we know that it's safe, we will activate this system. And obviously at the conclusion of operating hours, we want to make sure that those signs go back to the red X, right? Because this is a law. We don't need people saying, oh, it's we're getting notified that the lane is open. Well, that can't happen. So we kind of crutch on a scheduled system, but we have to verify that the system is going back to closed. Next slide. Thank you.
All right, thank you, Chris. Our next presenter is Jason Dicembre. Jason is the Director of the Office of Transportation Mobility and Operations for the Maryland State Highway Administration. Welcome, Jason.
Hey, good morning, everybody. Nice to be with you today. Maryland's implementation here is a little bit different in that our project is still under construction, but we've already learned a lot of lessons, and you've heard Liz and Chris and Jeff talk about some of the considerations, and I'll kind of bury the lead here a little bit. I can't stress enough how important the development of your concept of operations is for a system like this to make sure all your stakeholders are involved. So before I get into all that, a little bit about the project. Next slide. In Maryland, we are implementing a left shoulder, inside shoulder PTSU system around our Baltimore Beltway. In total, if you include both directions, it's a little under 40 miles total of PTSU, and is our first dynamic system. Well, we're referring to it as static dynamic. I'll get to that in a second. But we'll get into meat a little bit too, but the project area encompasses 6 of the top 15 congested roadway segments in Maryland. And as you can see, part of that is you have a lot of interstate feeder routes coming into this beltway here that is heavily traveled. To construct it, we went with the design build approach, and it is, again, still currently in construction. Go ahead to the next slide. Part of the need here, you can see, especially on the evening rush hour side, just a ton of congestion around this upper west side where I-70, I-83 is coming in. And so this particular corridor, there is not much real estate at all available to expand, even if we wanted to. So when it comes to treating the mobility problem here, PTSU was really the only viable solution. But we weren't just focused on mobility. Next slide. When we developed the project, we really, like any good ITS project, is going to sit down and figure out what our true goals are here. So yes, we wanted to improve mobility, but we also didn't want to lose sight of safety, right? So safety is always the first priority. How can we marry the two? We did want to maximize hard shoulder running, again, to increase that throughput there. But we also wanted to do it in such a way that it didn't tax the SHA operations and maintenance crews too much. And I'll talk a little bit about the implementation again in a second, but we also didn't want to limit the technology to what we currently use in Maryland. So I mentioned that this is our first implementation of dynamic part-time shoulder use. It's not the state as a whole's first implementation of dynamic lane control. So our sister agency at the Maryland Transportation Authority already uses lane control systems actively through their TMCs on the Bay Bridge and in their tunnel facilities. But for the State Highway Administration, it is our first foray into this area. But we didn't want to just look at what NPTA currently used. We wanted to allow industry to bring some innovation to the project, which again kind of led to that design build decision. I mean, of course, we also wanted to increase reliability along the corridor and have that ability to respond to non-recurring congestion issues. Next slide. Since it's under construction, I don't have a live photo to show you, but this is an artist rendering of kind of what a segment will look like. So again, left shoulder use with a lane use control signal. The project did require a complete CCTV coverage of the PTSU segments. So we will be getting some new CCTV cameras in addition to what we already have, plus some automated incident detection. There was a lot of discussion in the formation of this project about what that green arrow means legally and also to the public. Does it mean safe for travel, permitted to travel? What's the public perception? And how do we make sure that that lane is, again, as safe as possible to use when the public is used to thinking of it as a shoulder? So there is automated incident detection. That is going to be radar-based, not camera-based detection for us. The other thing with this project we were able to do through this project segment list was to introduce fiber. So in state highways coverage area in Maryland, not all of our devices are connected to fiber. So this project gave us the ability to lay some new conduit, make some connections to some fiber runs that were already there. Because of course, with a regulatory system like lane use control, we want to make sure that the uptime there is as best as it can be. Next slide. So some high-level lessons learned. I'm going to take 3 examples in our ConOps and in our high-level requirements we were developing. 3 examples and some of the conversations we had, and then some lessons learned from so far our build out of it. So the first is that the PTSU had to be able to be open or closed at predetermined times a day. Just for background, those times a day were determined through RIDIS data, and then also through some VISM models that we did for current and projected. I believe it was 2040 VISM models that we used to come up with those times. But again, we wanted the ability to open or close these lanes in times of emergency, whether that was the PTSU lane being blocked or needing to open it, like Liz was showing, for some incident management capacity building for accidents that may be happening towards the right side of the roadway. We needed to make sure it was compatible with our existing ATMS, but we didn't necessarily want to limit industry to having to use our ATMS. That was an interesting discussion there. Part of that just related on time to implement and actually build out our system. But we allowed industry to bring some items that we could then integrate with, not necessarily make it a module within our own existing ATMS, and I'll touch on that later. And then I mentioned it already, but again, an automated incident detection system that we felt was required for the safety of the system. So kind of talking through each of these in the next slide. For the opening and closing, right? So there's like 4 big things we were really talking through with this. How do you open or close the system dynamically? So when it comes to crashes, our current practice is to move the crash to the closest shoulder possible to get those lanes open, get our responders out of the roadway, and get traffic moving. And in cases where it might be a long-term incident, we may sometimes use the shoulder to run traffic or to release trapped traffic, but we don't routinely use the shoulder for constant movement of vehicles. So we had to talk through, well, how does this work now? So what about the accidents that our SHA teams aren't on scene of? So as we start going through traffic incident management training with our other partners, especially in the Baltimore area, we're emphasizing that, once the system is active, we need a concerted effort to, where possible, move vehicles off to the right and not the left. But that could mean needing to hold traffic temporarily while we, quickly move that over where possible. And then where it's not, the system is designed to suggest to the operators which segments need to remain closed and which can be opened in a safe manner. And that leads to the second bullet there, which is, okay, when an accident is occurring, at what point do you open that PTSU segment for that added capacity? It certainly isn't necessarily an all incident scenario. And like Liz said, there needs to be really good coordination with your on-scene responders so they can make sure their setup is correct for that to be opened, and that everyone understands what's going on. Next slide. For abandoned vehicles, so in Maryland, there's a law that allows a vehicle to be unattended on a controlled access highway for up to 24 hours. So changing that procedure, really, it would require a change in law, not just could require. So how do we handle that? So in Maryland, we're lucky that the Maryland Transportation Authority, the Maryland State Highway Administration, and the Maryland State Police have all come to agreement on using the MSP 23A form, which is their tag for unattended vehicles. So our safety service patrols, if you will, whatever they're called in your state, do carry these same tags you see there on the right-hand side, as well as the Transportation Authority. And so when they come upon an unattended vehicle, even the SSPs can place this sticker on the vehicle, relay that to the state police dispatch for their unattended log. So we're not waiting for a trooper to respond and tag that vehicle, so we can expedite the removal of that as soon as that 24-hour period is over. And that does mean we recognize that our chart units, our SSP units, if you will, may have to conduct some additional sweeps of that PTSU segment prior to activation to make sure that shoulder is clear. Next slide. So debris removal, kind of the same thing, where we tend to just move it to the closest shoulder possible, and then it can be picked up on the next business day. I brought this to the forefront because this actually goes outside of our operations offices and touches on our maintenance crews. So when we're discussing how we're going to handle debris, our maintenance teams had to be included there too, where normally, let's say there's a couch in the road and we move it to the left shoulder, it's understandable if that's at noon, that can be picked up maybe the next business day. Crews are out mowing or repairing guardrails somewhere. No harm, no foul. It can wait about 24 hours. That's not a huge deal. But when the PTSU is supposed to open at 2 o'clock, now what do? Does this become a higher priority for removal than it would be, during normal circumstances? So that has required a change in how we prioritize debris removal within the PTSU segments, even during routine hours here. And the other conversation, right, was even the right shoulder. So if there's debris now on the right shoulder, Liz mentioned in her presentation, making sure that there was a shoulder available for emergency services to use. So now if my right shoulder is blocked with debris and then I open my left shoulder, yeah, it might only be for a certain, small piece of the segment, but we have to look at then I technically have no shoulder available in that area. So even though it's on the right shoulder, it may still be a priority to remove within the PTSU segment. Next slide, please. The last thing when it comes to operational thinking, when it comes to winter weather, and like several others, Chris mentioned this, Liz mentioned this, but we also have the same thought. So one was in pre-treatment. Right now, we pre-treat all of our lanes. When there's a storm coming in our metro areas, we don't treat shoulders. So now that this is considered a lane, what do? Do we treat the shoulders? Do we not treat the shoulders? Our current feeling is that we're not going to treat the shoulders because from a safety standpoint, this was mentioned by one of the other presenters, speed can increase here with an added capacity. So during winter weather, probably not a good idea to have higher speed. So from a safety perspective, probably best to leave it closed. But in the event they do treat it and we do want to open it for some reason, we need to make sure that the center is aware that has been done. Also, we do have RWIS, road weather information sensors, along the corridor. But the operators now need to monitor those maybe more often and more closely than they did, because even though the roadway may be clear, re-icing conditions, black ice conditions, making sure that even though there's no obstructions, that the operator believes that it is safe to open. And then the reason the ConOps piece also comes in, our current practice, if you will, for 4-lane sections of roadway is to plow to the left. When we were first going through this discussion, before we brought in maintenance, there was a feeling that, well, we could just change that, right? And maybe just change it to plow to the right, which really doesn't make sense because you have a lot of on-ramps and everything around here. Would not make sense at all. but maintenance was the one that said, you know, hey, like, you're not thinking through this clearly, everybody. Make sure you're not changing our practice for us. So having that other view, right, of how it affects other people in the room was critical. So then it just turned into, okay, we'll continue to plow to the left, but after the storm is over, we'll just make it a priority and a goal of clear the PTSU prior to the next activation period after the storm has ended. Really quickly, next slide, a few other things touching on the other examples of ATMS compatibility. So our ATMS had never done any type of lane use control. MDTA, through their tunnels and their bridges, use a whole separate system to control those lucks. So we had to build that functionality inside of our system. So there was a lot of discussion of how do we do that? How do we visualize this to the operator? This is a landing page from the home screen the operator sees. If you were to look to the top left where it says events, when I took the screenshot, there were 91 events across the state of Maryland. That could be a crash, that could be a signal that's out, name it, right? Debris in the roadway, debris in the shoulder that needs to be picked up. So how do we visualize that to the operator? So you can see it's a demo by the text here. So this is still being built. But the idea here is that it'll list all the segments of the system. And if there's an event inside of that system or an alarm from the AID, they'll be able to see it here, be able to execute it. They'll also be able to see the status of any PTSU Lux devices that are in the area. The middle section you see for DSA is dynamic speed advisory. There are no DSAs along this particular project, but it's there. Next slide. The operator can then click a particular segment and they'll get like a lane by lane view that'll show the current speeds. Those are the blue indicators you see there that'll show the speeds in each lane. We're still building out the graphics again, but in the middle there, you'll be able to see the current status of the Lux at each gantry. And then some visualizations will be built for all the cameras that are in the area or all the dynamic metric signs that they could also see. Next slide. The last thing was the fact that it is a new system, right? So we had also never done in-state highway automated incident detection. So the RFP required a 10% or less false alarm rate. Now, my background is in TMC operations, so I read that and I'm just thinking that that's still a lot. But how do we put a number in there that the industry could meet and wasn't limiting? Goes back to that balance. We do, in talking to the winning bidder, we've been told that the false alarm rate will be less than 3%, which is a lot more manageable. A little bit how to operate those. So the current SOP, it will not automatically close the PTSU segments once the AID alarms. It requires an operator to verify that the alarm is valid and that there is an obstruction and then manually close that segment. And the reason for that is, again, not really knowing how many false alarms we're going to get. We wanted to limit any chance of weaving that would happen of segments off, operator clears the alarm, segments back on. So we just thought in the interest of the safety of preventing the weaving motions of the merging, that we'll let the operator verify it first. And then if we need to make that adjustment down the road, we will. And as far as the schedule time, once again, the current design does not automatically activate the PTSU at the designated time. The operator will get an alert that says it's supposed to activate in 30 minutes. Go through your checklist, verify there are no alarms, visually inspect the CCTV, images along the corridor, and whatever else we have, check the ARWA sensors, all the devices that we need them to verify it is safe to open, and then they can click the button. The system then knows upon the time frame to open, go ahead and open it. To manage this, though, some other folks here have mentioned, I believe Jeff mentioned, some other states had hired specific operators to strictly manage the PTSU systems. We didn't create a separate position yet. I'm going to emphasize yet, but we did proactively add in our org chart new positions, additional positions that are the same spec and classification of the current operators, but just more so we can dedicate them to PTSU until we see what that workload is, because we don't know how many alerts we'll receive per hour and really the level of effort it's going to take to inspect the PTSU segments and verify them. And we do recognize this may lead to needing to update our TMC operator specification because we do have regional centers as well as our statewide center. And right now, the vision is that this whole system, even though it's in Baltimore, will be managed by our statewide operations center, which is not far away. It's down near BWI Airport in Hanover. Next slide, which is my last. So some high-level lessons learned. Sell the why. Again, there was a lot of discussion at the beginning of this project about whether it needed to be dynamic or whether static would work. And ultimately, that flexibility of being able to open it and close it based on conditions and based on incidents was important. And also the ability to, like some other states have done, to add more traffic sensors and do it not as static, but full dynamic eventually if we wanted to. Let's build that capability in now. Ensuring that you do have a well-developed ConOps, especially in your operation scenarios, making sure everyone is there. Liz mentioned law enforcement. We had some of the same concerns from law enforcement, especially too from EMS about crossovers, because some of the crossovers in the segment are being taken out. So making sure they're part of the discussion and how we're going to manage these changes together and what this means for all of us into these different scenarios is really important. Provide enough time, especially in your software development, for any changes that you need. So yes, we can agree to have interface control documents between systems, but seeing it on paper and then actually connecting to each other and seeing some of the glitches that are inevitably going to happen, you need to build time for that. And I think sometimes in our experience, it takes even longer than we anticipated. We think it's smart, as some other states have done as well, to make sure your staffing's in place long before the system goes online. Do you overstaff and then adjust down in operations? And I will always tell you, my opinion is it is easier to scale down than scale up. So start with a large group in place, and then you can reassign to different duties if need be, but make sure that staffing is there before your system goes online. We think we're well adjusted for that when we do flip the switch here. And then lastly, we have realized that forecasting, the new maintenance cost for the system is challenging. So in Maryland, we are submitting usually 2 years ahead of time for our budget. So for example, in April this year, I'll be asked for fiscal 27's anticipated maintenance and operating costs. So since the system for us is not currently online and we don't really have good history for uptime and downtime and how many PMs we're going to need to make sure things do stay operational, what's the failure rate of certain components, it can be difficult. So just be aware that you might need to, have some margin of error, I'll call it, in your forecasting numbers. And again, it's easier to say I need a certain amount and back down from that than undershoot it and then have to increase it later. So that's it for Maryland, and I'll toss back to Jordan. I believe we're going to go into some Q&A.
Yes, thank you, Jason. All right, now is the time for questions and answers. So at the bottom of your Zoom screen, you should see a box that says Q&A. You can click on that and enter in any questions that you might have. We will give it a couple minutes as people think about questions they had from the presentations. Okay, first question. What other options did your agency consider for managing changing traffic conditions?
I can take a stab at this one. So in Wisconsin, can you all hear me? Okay, great. Yeah, in Wisconsin, after we opened our lane, we had reevaluated our operation times, and some of the things that we can do to change the operating times based on traffic conditions is change how the software interprets the traffic volumes and makes recommendations to the operators to open and close. The operators have the ultimate decision, though, in all opening and closing. With the speeding issue, there were some suggestions to open a lane partially in the area where we have more congestion than others. That is a really difficult thing to do because we found that the traffic conditions change so quickly on the corridor, and opening the lane takes time, right? So once you close part of the lane, to reopen it, it means that there's another, you have to recheck the closed section to make sure there are no obstructions in that lane. So opening the lane takes a lot longer than closing the lane. So adjusting based on current traffic conditions by opening and closing was not a practical solution for us. That was one thing that was considered in Wisconsin.
All right, John put in the chat, Elizabeth, how have you incorporated the performance of the use of the shoulder into your ongoing monitoring and reporting of performance within your agency to your partners?
Okay, yeah, good question. We have separate performance measures for the flex lane. As statewide measures, we do have delay and reliability measures that are statewide, and we report those measures on the interstates and the Beltline and this US highway section in Wisconsin. So that one hasn't changed. We've seen the performance improve drastically on that corridor that's reported along with our statewide measures. But we have separate performance measures for the flex lane. Our administration was very interested in how is it performing, and we've scaled back on those measures. We started out, and these performance measures were part of our concept of operations. So we had planned early, what did we want to measure performance on? And lane availability was one of those metrics. Based on anticipated frequency of crashes, weather conditions, outages, how often did we forecast that we would be unable to open the lanes? And we had set our target at having a 95% availability. And we've been delivering our every 6 months now, we've been delivering performance measures, and we have met that requirement or that expected performance. Other things are the reliability of the corridor, the travel times on the corridor, also crashes was one thing that is being tracked. The goal of the project was not to make things worse, right? Crashes are something we can't always control, but we've seen a significant decrease in the crashes on the corridor.
To that point, we have a couple questions. One asked, did you experience serious accidents during hard shoulder running or in open flex lanes? And what preventative measures did you take? And someone else asked, has the crash rate in the segment been impacted by part-time shoulder use?
Sure. From Wisconsin's perspective, the crashes we've had fewer crashes. Overall, fewer crashes, significantly, between 30 and 40% fewer. We haven't seen the flex lanes causing significant crashes. The trouble areas, the one I identified on the eastbound direction where we have the merging, and another on the opposite direction, there's an off-ramp that, because traffic is now moving so much more efficiently down the corridor, the off-ramp has become over capacity. And so we've had backups from the traffic and in that area. And so because of those two congested areas, we continue to see some rear end accidents in those areas, and they're not so much speed related as just the end of queue type crashes. We create events in our traffic management software to alert drivers that there's stopped or slow or stop traffic ahead. So we use static messaging when the queues are when they're forming and when they're present. But as far as crashes, breaking the crashes down into the different categories, the higher severity crashes has not seen the same amount of improvement that we've seen in just the rear end type and side swipe crashes. But in looking at these crashes, we're not attributing them only to the flex lane, but speeding, distracted driving, because a lot of them are happening in any lane, not specifically the left shoulder.
All right, and same question to the other presenters. How has the part-time shoulder use impacted your guys's crash rates, if at all?
So from Maryland, I'll defer to Chris here again. Ours is under construction, so I don't have any good data to show you yet. But what I will say is that is something we are looking at, right? We are aware that that could be another concern, right? Higher speeds, more throughput could mean more crashes. So we have that on our radar to make sure that we are tracking that once the system is live.
So I can tell you some of the past data that it has improved. Travel time data has improved, but I've seen some bad crashes over there. But luckily, I know DOT had a lot of cameras put out for that reason to cover our assets, to make sure that it wasn't something with the system that malfunctioned, right? And then we can say that, this was the motoring public that caused the accident, not a malfunction with our system. So you want to make sure that you have a vast coverage with your video cameras when using this system.
And Chris, just to let you know, I think your microphone was up on that one. We were able to hear you. It was just a little quieter. Okay, when conducting economic analysis, what did you use as the design life of the dynamic lane?
I'll chime in. I know that the PEL study is still ongoing in the Madison area, that the part-time shoulder lanes, they're not meant to be, a permanent solution to the transportation issues that are in Madison. The Beltline, that highway, it's kind of a tricky area because there's a lot of lakes, rivers, and there aren't really a lot of alternate routes in that area to take people from one side of Madison to the other. So there's an ongoing study for improvements. I don't recall any specific design life, though. I mean, we have, maintenance and replacement expectations for some of the hardware that we have. And there's expected pavement life and wear and tear and maintenance as those things go, but we didn't have an overall system end of life.
Pretty much the same from Maryland. So we are upgrading some things. There's gonna be some additional drainage inlets added. There's gonna be some upgraded barrier walls. And we will repave a large part of the segment, but we didn't calculate an end of life for the system. It's going to just be routine upkeep. And similar to what the other states have shown, there is a truck restriction to that lane. So it's meant only for passenger vehicles to make sure that that can sustain right as long as possible before we have to do some structural changes there.
Will there be a high number of fines for using the part-time shoulder use outside of indicated hours? And how has this impacted the enforcement side?
Sure. Yeah, I'll chime in again on this one. Using it outside of hours. So the first 2 weeks or 3 or 4, I think they were pretty generous. Law enforcement enforced the use of the lane, and they issued a piece of paper that was instructions on how to use the lane. So they took advantage of that those first few weeks as sort of an education period. And then after that period, they are citing drivers. They cite them for speed if they catch them. Also, they will cite them for, I think the citation is driving in a closed lane or something like that. I don't have the exact wording in front of me, but they do write tickets for when they catch people that are in the lane that when it is closed. I think it might be disobey a traffic sign also because it's signed above the lane. You can drive in the lane on green arrow only. So it might be violation. I think it might be one or the other.
Okay, Jason, did you need to include an estimate of staff support and include the project into your and your staff's work plan to support the planning and development of the project into your operating budget to ensure the operating center's needs were being incorporated into the design and construction project?
Yeah, great question. So in Maryland, all these forces are all of our chart units in the field, and our TMC operators are state personnel, not contractual. So it was not a cost estimate added to the project, but it definitely was part of the operating budget that we had to submit some increased requests there for our internal staffing, as well as the request for the additional positions that we had to add. So yes for operating, no for the overall project.
Has there been a need to implement variable speed limits within the part-time shoulder use segments?
In Wisconsin, it would take legislation for that to be allowed. We currently aren't able to operate variable speed limits on any of our highways.
Yeah, so from Maryland, again, it's not active yet. I'll have to double check. We do not have any plans for variable speeds within the PTSU corridor. And similar to Elizabeth, I believe legislatively, the only place we can use variable speed limits right now in Maryland, that regulatory anyway, speed changes is in work zones.
New Jersey does not.
For Elizabeth, what is the policy for abandoned vehicles? Will the flex lane open in segments if an abandoned vehicle is within that flex lane?
Right. No, the flex lane won't open if there's an abandoned vehicle in that segment. This is the policy on towing vehicles was something we talked about in the years leading up to opening during the design, because abandoned vehicles, they're just on shoulders, right? What do you do about it? So there is a policy for considering it a hazard tow. So we had two different categories for towing vehicles. A vehicle that could, be abandoned if it was not in a place that was hazardous, could remain. But if it was deemed hazardous, we could call for a tow for that vehicle immediately. We monitor the lanes so much. There's only been a handful of times where there's been an abandoned vehicle that has appeared, say, at 2 or 3 in the morning, and our third shift will notice that and call the dispatch and have someone come out and tow it before the peak hour. But so there is a difference between towing and anything that's in the flex lanes is considered a hazard.
All right, thank you. And thank you everyone for your questions. Sorry, we were not able to get to all of them, but we want to be respectful of your time. Before we wrap up, we have a few more slides. We want to remind you all how you can stay connected to the pooled fund study. On your screen, you should see a list of recently completed projects by the pooled fund study, including one pending publication. A reminder that you can find all of this information at the TMC Pooled Fund Study website, as well as the NOCO portal. And honestly, if you guys have not checked it out, there is a ton of great information on probably any challenge or concern that your agency might have, any options that you guys might be considering. You should check out one of these sites and see all of the research that has been conducted and use that to make more informed decisions. Next page. Here is a list of the next 6 webinar topics, as well as tentative dates. So please be on the lookout for those. You can also register for the webinars at the website provided. If you are interested in being a speaker for any of these, please contact John Obenberger at the email provided on the screen. Next page. And on the NOCO portal, it is not only a resource for you, but an opportunity for you to provide information to help others as well. So you can see circled on the screen, there are locations where you can submit examples or practices that your agency is currently doing or has input on, as well as new research ideas that the pooled fund study can consider. Next page. All right, and with that, I will hand it back to Matt for a closing poll.
All right, everyone. Thank you, Jordan. Let me just, one moment, please. I'm just going to open the closing poll. These are 2 short answer questions for you. You can probably see both of them on your screen. Just please take a moment to answer those questions. Okay, we're gonna close the poll just because we're short on time, and as Jordan mentioned, we want to respect everyone's time. Okay. And in closing, I want to thank everyone for attending today's webinar today. I also want to thank our moderator, Jordan, as well as our panelists, Jeff, Elizabeth, Chris, and Jason. We had a great discussion here today, as indication of going over, as I always like to think. As I mentioned in the beginning, a recording of this version of the webinar will be available on the NOCA website, usually within 2 to 3 business days. On behalf of the National Operations Center of Excellence, again, thank you to our panelists, and thank you for joining us today, and I hope everyone has a great day.